Oil liquid table part 2. I've already set up view number 2 on this meter to see the liquidant. And just as a reminder, the liquidant is the sound speed, which has been corrected to 60 degrees F in this case. What we're also showing is the medium temperature, which is the temperature of the liquid inside the pipe at the moment, and the density, which has been standardized, so it's standard density. And when we say standardized, that's to base conditions, which is, in this case, 60 degrees F and 1 bar. The reason why I choose to show the medium temperature is because I want to make sure that I'm dealing with a live temperature. And in this case, I just have my hand on the RTD, and you can see that the temperature is changing, and so is everything else, the liquidant and the density. If I let it go, it should settle out. To set up the temperature, you have to go into setup. You have to find the inputs and outputs. And in this case, I have set channel 5 for medium temperature RTD. It's 1,000 ohm RTD. And I only have about 2 inches of wire on this RTD because it's just for a test. But if you know the resistance of the wire per foot that you're using, you could multiply that by the number of feet and come out with the true resistance. I also want to make sure that the values are in the units that I want to see them in. Liquidant as meters per second, my medium temperature I want in Fahrenheit, and I want to see my density as kilograms per cubic meter. So I'll go down to process values. And liquidant is going to follow whatever my sound velocity is set to. In this case, it's meters per second, but as you see, there are other choices. As far as density is concerned, that's set to kilograms per cubic meter. And the medium temperature is set to Fahrenheit. I'll just mention that we don't have a pressure feed into this meter, as pressure does not have a large influence on the density as does temperature. The next thing that I'll need to do is set up the local display to look like this. So I'll go in to setup, local display. In this case, I chose view 2. 3 values: liquidant, medium temperature, and standard density. I like to choose standard density because I'm more interested in seeing what the reported density is at base conditions. And just to remind you, base conditions is, in this case, 60 degrees F and 1 bar of pressure, never minding the fact that we're not using pressure in this instance, as its influence is really negligible. In this example, I have crude oil in the pipeline, and you can see my liquidant is 1358. So I'm going to write that down, 1358. And what I want to do is find out what the actual density is for this product. So I'm going to have to check with the customer. Hey, Mr. Customer, there is this grade of crude oil in the line. Can you tell me what the density is? And most likely, he will give me a density as an API, which is American Petroleum Institute, and I'll have to do a conversion to put the correct number in for the table for this point. Now, I've made this calculator, which I will include in the link, and what I have to do here is put in the number that I wrote down in the earlier step, 1358. I have to select what the product type is, and I have to put in what the customer has told me the base API is for this particular product. And in this case, he has told me that the API is 35. And that'll give me a kilograms per cubic meter of 849 and change. I'll also have to write down what the K0 and K1 values are, which have been calculated by this tool. Now, when you're creating a table, there's going to be some wander in terms of the liquidant for that product. So what I like to do is, instead of just editing 1 point, I like to make 2 points. And what I've done is I've added a liquidant bandwidth. In this case, it's 4 meters per second. And what this will do is this will calculate the 2 points that I want to enter. In this case, it's 1354 and 1362. So let's go into the